quantum numbers. So how many types of quantum numbers are there? 4 types. First one was principal quantum number. How can we denote this? By small n. It tells about the energy of different electrons filled in different shells. What is the value of n for K shell? It is 1. For L, it is 2. For M, it is 3. If value of n increases, then energy also increase, beta. Energy also increase. Okay. So from here we can say that the electron filled in M shell, they have more energy than L than K shell. Okay. Or principal quantum number also tell about the size of the atom. Okay. For example, if we take hydrogen, what is the atomic number of hydrogen? 1. So we can fill maximum 2 electron in K shell. Okay. So here only 1 cell is present because 1 electron can be filled by us only in K shell. Okay. But if we want to fill electrons in different energy level for sodium, what is the atomic number of sodium? 11. So in first shell, how many electrons are there? There are 2 electrons in first energy level, K shell. Okay. Then in second is L. Okay. So in L shell, how many electrons? There are 2 because we can fill the 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Energy level, we can fill electron by formula. Which one formula? 2n square. Okay. So for L, value of n is 2. So maximum we can fill 2 into 2 square. So 2 into 4. In L shell, we can fill maximum 8 electron. Okay. Then we will fill the electron in M shell. So we have already filled 10 electrons. For M, we have only 1 electron. So 1 electron will be filled in this. So you can see, in case of hydrogen, 1 present filled in 3 shells. Okay. So if number of shell increases, then size also increase. Okay. From here we can say that size of sodium is greater as compared to the hydrogen. Clear or not? Students, we can calculate number of orbitals by knowing value of n only. If we know about the value of the principal quantum number, then we can calculate total number of orbitals also. By which formula? By formula n square. 2n square, this formula is used for calculating number of electrons. Are you getting my points or not? Yes. So formula 2n square, it is used for calculating number of the electrons. But n square only, this is used for calculating number of orbitals. For example, If I say, if value of n is 3, so how many orbitals are there? How many orbitals are there? 9. So number of orbitals. If value of n is 3. So orbitals we can calculate by formula n square. So orbitals will be 3 square, 9. How can you say that? For value of n is 3. What will be the value of L? We have already discussed in previous class. L is the azimuthal quantum number, angular quantum number. If we know about the value of the principal quantum number, so we can calculate azimuthal quantum number also. So how can we calculate? 0 to n minus 1. 0 to n minus 1. Okay. So here n is 3. So what may be the value for L? Value for L may be 3 minus 3 minus 1, 2. So it may be 0 to 2. It may be 0 to 2. Means either value of L may be 0 or it may be 1 or it may be 2. Okay. You know very well, if value of L is 0, then which orbital is here? S. For one orbital P and for 2 orbital D. You know very well. How many orbitals are present in S? Orbitals are present. Only one? Only one orbital. Because it is non-directional. Only one orbital is present in S. And in case of P, how many? 3. Px, Py and Pz. There are 3 subcells. Okay. And for D, there are 5. For D, there are 5. 1, 2, 3. 1, 2, 3, 4, 5. There are 5. dxy, dyz, dzx, d x square minus y square and d z square. Very good. So you can see how many orbitals are here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So for value of n 3, there are total 9 orbitals. And directly we can calculate by using this formula. By calculating value of n square, we can calculate how many orbitals are there. Okay. We can take one more example. If value of n is 4, so maximum orbitals may be present here 16. Which formula you have used? N square. So here value of n is 4. So 4 square is 16. Okay. And if we want to calculate with help of the L value, again we can calculate. If n is 4, then value of L may be 0, 1, 2 and 3. Okay. This value 0. This is for S. 1 for T, D and F. You know very well how many orbitals are present in S. There are only 1. In P there are 3, Px, Py, Pz, and in 5, and in F 7. So total 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16. Okay. So there are total 16 orbitals. Okay, and if I ask about number of electrons, so how many electrons are there? Number of electrons. You know very well, you can calculate number of electrons by using the formula 2n square. So if n square value is 16, so 2 into 16, 32 electrons. We can fill maximum. Because in one orbital, we can fill maximum 2 electrons. So there are total 16 orbitals. If orbitals are 16, so we can fill 16 into 2, total 32 electrons. It is clear to you or not? Yes. Students, if we know about value of n and l, we can also tell about the orbital of that electron, subcell of that electron. For example, if value of n is given as 4 and value of l is given to 2. So, which orbital it is? Can you tell me or not? N is 4. And for which value of L is 2? For which subcell? D. So it represents for D. Clear or not? If you have value of N is 5 and L is 0. L is 0. So it represents 5s. Clear or not? Are you able to solve this? Yes. Okay. So now you will discuss some rules which are used for filling electrons in different orbitals. Okay. First of, there are mainly 4 rules. First one is Aufbau Principle. After knowing these rules, we will be able to write electronic configuration of electrons. Okay. First one is Aufbau Principle. Second one is N plus L rule. Third one, pauli-exclusion principle. And fourth one is Hund's rule. What do you mean by the Aufbau principle? It shows that electrons are filled in different orbitals. Electrons are filled in different orbitals in order of their increasing energy. What do you mean by this? Means, first of all, we will fill electrons in orbital which have lower energy. After filling the orbitals of lower energy, we will move in higher energy level orbitals. It is clear to you or not? Okay. So, how can you tell about the energy? Which one orbital has lower energy, which one has more energy? Okay. So, that can be calculated by using this rule, N plus L rule. Okay. If value of N plus L for any orbital, if this is more, if value of L, N plus L increases, then energy of that orbital energy of that orbital also increase. For example, if I have 1s, 2s, 2p, 3s, 3p. Here, what is value of n? 1. Value of n is 1. And value of L is 0. For S it is 0. So, n plus L. N plus L value. It is 1. Okay. Here what is value of n? 2. Value of L is 0. For S it is 0. Total n plus L is 2. Again, value of n is 2. And L? For P, L is 1. So total it is 3. Then n value 3. S and L is 0. Again it is 3. Then 3p. When value of n is 3. Then 1. Total 4. Okay. For 3d. Value of n is 3. Value of L is 2. N plus L is 5. 4s. N 4. L 0. Total 4. Students, you can see that here value for 1s, it is lower value of n plus L for 1s. It is lower as compared to the value for 2s. So energy of 1s is less than as compared to energy of the 2s. Clear or not? So in easy way, you can write in this way. First of all, we will write 1s. Then 2s, 2p. 2d do not exist. We have already explained in previous class. 1p also not exist. Okay. Then 3s. Then 3p. 3d exists. Then 4s. 4p. 4d. And 4f. Okay. First of all, this is trick only. In this way, first of all, you can fill electron in 1s. Then first of all, you can fill electron in 1s. Because it has lowest energy. It has lowest energy. Then in 2s. After that 2p. Then 3s. Then 3p, 4s, 3d, 4p. Okay, in this way. So 1s, 2s, 2p. Then 3s. Then 3p. After 3p, we are not filling electrons in 3d. After 3p, we are filling in 4s. Why? Because for 3d, value of n is 3 and value of L is 2. What is the value of L? It is 2. So 3 plus 2. Value of n plus L is 5. But for 4s, value of n is 4. This is value of n, 4. And value of L, for s orbital it is 0. So 4 plus 0. when value for n plus L is 4. It is 4. So here 3D has more value, more n plus L value. Okay, as compared to the 4s orbital. So first we will fill 4s, then we will go to the 3D, then 4p. In this way means we will see n plus L value for different orbitals which has a less value of n plus L. Okay, so energy for that orbital will be also less, and if value of n plus L is more, then energy will also high. It is clear to you or not? But student, in some cases, like you can see, for 2p this value is 3, and for 3s it is also 3. For 3s it is also 3. So if value of n plus L is same, then you will see value of n only. Then you will see value of n which has lower value of n. You will fill electron first in them, then you will fill in that energy level which has more energy or more value of n. So here 2p it has, here 2p it has n plus L value 3, and 3s it also has n plus L value 3. So first of all, here value of n is lower in case of 2p as compared to 3s. So you will fill electron in 2p first, then in 3s. This is clear to you or not? It is clear? Okay. Our second rule, n plus L rule, we have already done. Now pauli-exclusion. First of all, filling electron we can see according to these also. So first energy level is 1s, then 2s, then 2p, after that 3s, after that 3p, 4s, after 4s 3d, then 4p. Okay, so if we want to fill electron in hydrogen, what is atomic number of hydrogen? It is 1. In s orbital we can fill maximum 2 electron. In p we can fill maximum 6 electrons, because there are 3 orbitals, px, py and pz, and in one orbital we can fill maximum 2. So there are 3 into 2 6, we can fill maximum 6 electrons, and in case of d we can fill maximum 10, in case of f 14. Okay, so according to Aufbau principle, first of all we will fill orbital of lower energy level completely, then we will move to orbital of the higher energy level. Clear or not? So now try to fill electrons in some orbitals. For hydrogen we have only 1 electron, so this is s orbital, 1s. It is, first of all we will fill electron in 1s, and in s orbital we can fill maximum 2 electron. So but we have only 1, so we can fill in 1s only. So 1s1, this is configuration of a hydrogen. Clear? If we want to fill in lithium, what is atomic number of lithium? 3. First of all we will fill electron in 1s. In s we can fill maximum 2 electron. We can fill maximum 2 electrons. So 1s 2 electron we have filled. So we have now 1 only. So after filling this completely, we will move to the next energy level, and next energy level is 2s. So this electron we will fill in next energy level. So what is the configuration for lithium? 1s2, 2s1. Clear or not? If we want to fill in sodium, what is the atomic number of sodium? 11. Okay. Please tell me configuration of this. Fill it. 1s2. Good. 2s2. After filling 2s, we will move to the next energy level. Next energy level is 2p. And in p orbital, we can fill maximum 6 electrons. Okay. So 2p, 6. Okay. Then 2, 4, 6. 2 and 2, 4 plus 6. 10 electron we have filled. Now we have only 1. And after filling 2p, we will move to the 3s. Okay. Then S1. So this is the configuration for sodium. Clear or not? Yes. Any doubt in this? If you want to fill in scandium, what is the atomic number of scandium? It is 21. It is 21. Okay. So how can you fill the electrons? First of all, you will fill electron in 1s. We can fill maximum 2 electron in S subcell. Then we will move to the 2s. How many electron we can fill maximum? 2. So 1s2, 2s2. Then move to the 2p. Maximum we can fill 6. Then 2p, 6. Okay. Then in 3s, we can fill maximum in S. We can fill maximum 2. So 3s, 2. Then move to the 3p. Again in P, we can fill maximum 6. Okay. Then in 4s, we can fill maximum 2. How many electrons we have filled? 2, 4 and 6, 10. 10 and 2, 12. 18, 20. But we have 21. So one more electron we have. After 4s2, we can fill electron in 3d. In 3d, we can fill maximum 10. But we have only 1. So 3d, 1. So this is the way to fill the orbitals. First of all, we will fill the lower energy level orbital completely. Then we will move to the orbital of higher energy level. Okay. Some exceptions are there. Okay. Like in chromium. Chromium 24. Okay, what will be the electronic configuration for this? Tell me. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 4. Okay, but student, this configuration for chromium is not right, because this is exceptional case. Why it is, I will explain. Okay, by explaining next rule. Okay, our next rule is the pauli-exclusion principle. Aufbau principle is clear to you or not? Yes. Pauli-exclusion principle. This principle states that no two electrons, in an atom, no two electrons in an atom can have same set of all four quantum numbers. This statement is clear to you or not? It is clear. I think it is not clear to you. Now try to understand. No two electrons in an atom can have same of all, can have same set of all four quantum numbers. For example, if we have two electrons in 1s2 orbital, means in 1s orbital we have two electron. Student, there is a rule, Hund's rule. Hund's rule. Hund's rule says that in any orbital, first of all, we will fill the electron singly. Then we will start to do pair. Then we will start to pairing. But in pairing, if one electron has a high spin, then second electron will have lower spin. Second electron will have lower spin. Okay. So if we want to let us consider it is 1s. There are two electrons. It is completely filled. And we want to calculate all quantum number for this. So three quantum numbers value may be same, but all four values for two electrons will not be same at any time. This is the rule. Clear or not? For this you can calculate both electrons are present in same orbital. Both electrons are present in same orbital. But their value, calculate. What is value of N? 1. Value of L? 0. Value of ML? Magnetic quantum number value. Again, it exists from minus L to plus L. So, it will be 0. But value of spin quantum number, it is not same for both the electron. This is plus half for the electron which has high spin, and it will be minus half for this electron which lies in low spin. Clear or not? So value of electron, it is minus half. Okay. So this principle states that no two electrons in an atom can have same set of all four quantum numbers. Three quantum numbers may be same, but all four may not be the same. Clear to you or not? Any doubt? Hund's rule, I already explained, but I am explaining again. Hund's rule. Hund's rule. It tells us if we have electron, for example, if we have oxygen. What is atomic number of oxygen? 8. So electronic configuration 1s 1s2 2s 2 2p 4. Okay, so here in 2p how many orbitals are in p? How many? 3. So electrons we can fill in this way. Can we fill or not? No. This is not right way to fill the electron. According to Hund's rule, first of all, we will fill the orbital singly. First of all, we will fill single electron in all orbital. Then we will start to pair. So this is the right way for filling the electrons. Clear? Any doubt in any topic? Okay, so thank you. Have a nice day.